So basically, we are coming from the product for ECOFUNC, and we are targeting two major global challenges. One is climate change due to CO2. I guess most of us have suffered heat wave in Europe this week and past week. So, and the one of the major one of the major cause is because of the emission of CO2. And another issue is the plastic pollution. Like the microplastic have caused a lot of issue in ocean, also in soil, and also it is difficult to deal with because the plastic is used so widely. And for us, CO2BioClean, we transfer the waste CO2 into the biopolymer with our own BioClean technology. And then we can use the biodegradable polymer to make products. Those polymer are bio-based and fully biodegradable. So basically, we targeted in two field of CO2. One is biogenic CO2, for example, biogas, and also waste biomass. So when we ferment and when we throw away this trash from the, for example, food industry, there's a lot of carbon source that is wasted. It will be transformed naturally by microorganism into CO2 and it becomes the CO2 emission. And another is industrial levels of emission in these chimneys. So what we do is we are going to use both sides into our fermentation. So yeah, so you can see either it's an emission or it's in the biomass level. So the basic diagram is shown here. So we use waste biomass hydrolyzed into sugar, for example, glucose and fructose, or we use a waste industrial emission and we separate into CO2 and we plus hydrogen. Then it will go into a bacteria bioreactor. We will ferment, and then this bacteria will produce biopolymer. With extraction, we get these fragments, and with further downstream process, we will get the shaped biopolymer product and make into raw products, raw polymer, and make into the final product. So yeah, and what we do is to also with our technology to add some co-substrate, because naturally the PHA is produced mainly P3HB. It is very brittle and difficult to process. And with our special fermentation process, we add some co-substrates, and so the bacteria can use the co-substrates combined with the natural P3HB, and then it will have a polymer which with much better characteristic in all kind of aspects. So basically our value chain is like this. So first we get the waste carbon, and then we, with our CO2BioClean technology, we transfer this carbon to biopolymers, and then the biopolymer will be processed into compounds and then finish the products. So, and this is our fermentation technology, because for now we are a pilot plant. So we do it from the research level to the pilot level. So you can see, first of all, we test everything with a shaking flask. Then we test the fermentation capacity with the 3-liter bioreactor. If it works well, we will transfer it to 150-liter bioreactor and then 420 bioreactor to gradually scale up. Because either using hydrogen or hydrolyzed sugar is challenging in the scaling up processing. And after the scaling up of the fermentation, we will bring it to the extraction. We develop our own extraction method without any hazardous solvent while maintaining the extraction efficiency. So this is another breaking through that we are trying to scale up into the industrial scale. So, and what we are looking for is we look for the material testing partner for thermomechanical processing and biodegradation related evaluation. Because like I said, we use all kinds of co-substrate to improve and produce different polymer. And we would like to know if the polymer is as good as we expect. And also we look for application feedback partners to define useful target specification for PHA grades So how good they are, if they can be applied into the field and with a good property. And of course, we want to have this industrial partner who would like to have this small batch material evaluation. Like, how do you guys think if you guys can use our material? And we look for CO2 or downstream owners that they would like to cooperate with us to build up a circular carbon to material pathway. So basically, that is all the basic information. Thank you for many thanks to ECOFUNC for holding this, and thank you very much for the attention.